Okay, so this one is not as easy to draw as the surfaces of revolution, but I'm going to give it my best shot. And but the good thing about it, I'll show you how you don't really need to draw a good picture to be able to do these. So first I'm going to give it a little bit of a perspective. So my axis, I'm going to draw it tilted. Okay, and so the volume of the solid has a base enclosed by y equals x squared and y equals 3. Okay, so if I draw y equals x squared, and let's just say that this is 3. So this is the base. And now it says that the cross sections are perpendicular to the y-axis and are rectangles of height y cubed. Okay, so if I draw several cross sections here, so basically what it is that we have rectangles coming up out of here. And the height of these rectangles are y cubed. And so here, that's one rectangle, and then here's another rectangle. So these are examples of the cross sections. And so if you put them all together, make infinitely many rectangles, you'll get a surface where each cross section is a rectangle. Now let me put one of the cross sections right here. So this is a rectangle. It's basically one of these, and the height is y cubed. And now the base, well, if you look at this, the base is how wide the parabola is. Well, so here, this is, let me make sure that we're on top of this. This is the x-axis, this is the y-axis. And so, if you look at this, well, this is the graph is y equals x squared, but if you write it in terms of y, this would be the square root of y, right? And so the base, so if this is square root of y, and this would be negative square root of y, then what it is the base is going to equal 2 times the square root of y. Okay, and so this is the area of, well, my cross section is just a rectangle. And so to find the volume, all I need to do is take the integral of the area, which is base times the height. So this is going to be 2 y to the, well, this is y to the 1/2 plus 3. Well, that's y to the 7/2 dy. And then remember that the limits of integration have to be the same as these, so it has to be with y. So y goes from 0 to 3. And so that's my setup. And notice, I mean, you don't really need to be able to draw the picture well. I mean, I didn't even do a good job with this one, but what you really need is the area of the cross section, so figuring out the area of the cross section, and to do that you just need, in this case a rectangle, you just need the base and the height, and the base you find it by looking at the graph and figuring out how long it is from one side to the other, and the height, you're given the height. And so that's it. So now all I have to do is solve this. So let me start it over here on the left side. So what we have is 2y to the, if I add 1, this would be 9/2 times the reciprocal, which is 2/9. And this is going to be evaluated from 0 to 3. So this is equal to 4/9 times 3 to the 9/2. 4/9, 3 to the 9/2 minus 0. So I don't worry about that one. And so this is approximately equal to 62.35. And that's it.